Hi everybody, welcome back to Calculus 2 by Example. In this video we're going to be looking at an example of partial fraction decomposition. With partial fraction decomposition, you want to look at integrands where you have a fraction and the denominator is a polynomial and the numerator is a polynomial of a lower degree. And we want to break the fraction up so that we can sort of make the degrees in the denominator as small as possible, because all polynomials could be broken down into either linear factors like lines, functions that look like lines, or expressions that look like lines, or certain quadratic factors. Okay. So here I'm actually using an integral that you might recognize from an earlier video, the one I did on trigonometric substitution. And I chose to do the same integral over again to demonstrate that there's frequently more than one way to evaluate a given integral. We should hopefully get the same answer. Okay. So 1 minus x squared is a difference of two squares, and so we could rewrite that as 1 minus x times 1 plus x. And so now I want to find a way to rewrite this integral as an integral that looks like this, where I have a constant over 1 minus x plus another constant over 1 plus x. All right, so I have to work, or we have to work to make those two integrands match. So I want 1 over 1 minus x times 1 plus x to match the constant a over 1 minus x plus the constant b over 1 plus x. If we imagine finding a common denominator on the right-hand side, we would rewrite this as a times 1 plus x plus b times 1 minus x over the quantity 1 plus x times 1 minus x. Now, all the way over here on the left, I have a fraction with denominator 1 minus x times 1 plus x. And all the way over on the right, I have a fraction with the same denominator. So if I want two fractions with the same denominator to be equal, that means their numerators have to be equal. Okay, so setting the numerators equal, we can now try and solve for a and b. In this very basic example, there's a nice clever way to do this. If I let x equals 1, the first term becomes 2a, and the second term is 0. So I have 2a equals 1, or a is 1/2. And if I set x equal to negative 1, I get a term of 0 plus 2b. And so I get 2b equals 1, or b equals 1/2. So in this case, in this particular example, a and b are equal to each other. And so we have a equals 1/2 and b equals 1/2. Making the substitution, this gives me the integral from 0 to 1/2 of 1/2 over 1 minus x plus 1/2 over 1 plus x. Using techniques we've already learned and some basic integral rules, the antiderivative of that integrand will be the natural log of 1 plus x minus the natural log of 1 minus x. And notice that I have absolute values in there because we don't want to take the natural log of a negative in this class. And evaluating this between the limits of 0 and 1/2, it simplifies to the natural log of the square root of 3. If you're not quite sure how that works, go back and give that a try for yourself to make sure that you remember your natural log rules or your log rules. Okay, so that's an example, a very basic example of partial fraction decomposition. Again, the idea is to take a fraction that's a little complicated, in particular a fraction with a polynomial denominator, and rewrite it as a sum of fractions with simpler denominators. Okay, then that will make it easier for us to find the antiderivative. So just like all our other integration techniques, you take a complicated integrand that we don't know how to evaluate, and you try and break it down into a simpler integrand that we do know how to integrate. All right, so that's an example of partial fraction decomposition. That's our last technique of integration that we're going to look at in this video series. In the next chunk of videos from this series, we're going to talk about sequences and series, which are infinite lists and infinite sums. And so I will see you later for that.